Good day everyone. So we will now discuss the topic regarding the what we call boundary layer. Okay. So the concept of this boundary layers is actually the central to understanding convection heat transfer between a surface and a moving fluid, right? So say the surface, and there is a fluid um, flowing through this surface. Okay, so we need to understand the concept of the boundary layer to understand the convection heat transfer between the two. Okay, between the surface and the fluid flowing passing it. Okay, so the concept of the boundary layer began with Sir Ludwig Prandtl. Okay, so yes, Sir Ludwig Prandtl is also the one behind the Prandtl number. So the concept of boundary layer is also began with Sir Ludwig Prandtl. Okay, so he has a paper called On the Motion of a Fluid with very small viscosity. Okay, so it actually began here in his paper On the Motion of a Fluid with Very Small Viscosity, which was he presented it at the I think the Third International Congress of Mathematics in August 1904. Okay, so the idea behind the boundary layer is simply to describe. So Sir Ludwig Prandtl described the fluid motion when taking into account the friction, diba? The surface and the fluid which is in contact. So he described the fluid motion when taking into account these two things, the fluid and the surface, wherein he take into account the friction. Okay. 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 So the region within the bounds of the layer is where the effect of the viscosity is significant, and this layer is very small. Although originally the boundary layer was developed in terms of fluid velocity, but it is extended up to the temperature. Okay, so actually I mean Sir Ludwig Prandtl has an experiment regarding this, and it simply he has a setup of the of his experiment. Okay, so say let me try to illustrate his simple setup regarding this concept. So he has a something like this. No. So this is the table, and this is actually set up, and it has a something like a something like a paddle here, and this is being rotated to make a flow inside this setup. Okay. Okay. So let me illustrate this inside view so that we can easily understand the setup of Sir Prantal. Inside side view, say this is our, oops, sorry. Say this is the table. This is the table. And the setup, experimental setup, looks like this, which has a division and some cylinder here. So inside this, there's a cylinder inside. Okay, so there's a cylinder on this side, and there's a wheel or paddle inside this area. Okay, and it is actually being rotated so that the flow of the fluid moves here to here. Okay. So this is the setup of the experimental setup of Mr. Prandtl to describe the fluid motion when in contact, when in contact to some materials, and taking into account the friction between these two, the fluid and this material. Okay, and if we take a look naman in the top view, say this is a top view, we can see that, say this is our cylinder, and we have here our paddle, right? It's our paddle, and if we rotate this paddle, the fluid will flow continuously. Okay, and if we view the fluid flow, so from here it will move until such time that it reaches this point, and then having a contact between this cylinder C. Okay, so the fluid flow will looks like this. And something like that, right? So based from this experiment, the concept of the boundary layer has been has been studied. Okay, so that is actually the very simple experiment from Sir Ludwig Prandtl. Okay. And if we take a look at this experiment, the say this is our surface, say this is the surface, and we have here our flow, right? And if we take a look at this in this layer between this surface and the fluid, you can now view that there is actually a velocity profile that is being viewed between these two surfaces, between this layer. Okay, so according to Sir Prantal, we can see that between these two, we can now have this velocity profile. Say this is the top. This is the outermost or the outer edge of boundary layer. Okay, so if you view this from this point out to the outer edge or the end of the boundary layer, we can, according to the experiment of Sir Ludwig Prandtl, we can see that there is actually the velocity profile of the fluid will looks like this. So at this point, at the contact of between the contact, the surface, and the fluid, so the velocity here actually is 0, and then as we move along to the outer edge of the boundary layer, the profile actually, the velocity profile actually looks like this, having this kind of what you call this, description between the velocity. Okay, so from 0 out to this profile. Okay, so that is based on the experiment of Sir Ludwig Prandtl on the concept of the boundary layer. Okay, so on the next video, we're gonna continue this discussion regarding the boundary layer, but like what I have also said last time, that regarding this boundary layer, we have the what we call the velocity bound, the external flows boundary layer in external flows, and we have the boundary layer in internal flows. Okay, so it simply means that different profile, we have a different profile when our condition is in terms of external flows, and we have also a different profile when we have internal flows. Okay, so on the next video, we're gonna tackle more regarding this two, the boundary layer in external and internal flows. So see you on our next video.